All right, in these notes, we're going to talk about 6.2, which is more parallelograms, and talking about special parallelograms. We're not so much going to do 6.3, but these are just notes that we've used in the past. We're going to briefly talk about what 6.3 would be. So looking at these four pictures here, we have this is a parallelogram, this one's not a parallelogram, this one is a parallelogram, this one's not a parallelogram. So just looking at these four pictures, try to think about why you think these pictures, why some of them are parallelograms and why some of them are not. Okay, go ahead and write in a few words here why you think that is. So parallelogram, why are these two, the first and the third parallelograms, but then the other two not parallelograms? Hopefully you're noticing that, well, these have four sides, so this one about over here does not have four sides. Maybe that has something to do with it. And then maybe something about how this side is shorter than this side, while the other two have somewhat equal parts there, just by looking at it. At least that's what it looks like. Okay? So let's look at the theorems that actually make a parallelogram. So for the first one says that if we have a quadrilateral and the quadrilateral is a parallelogram, then the opposite sides are going to be congruent. So remember, this word congruent means they're going to have the same measurement. They're going to be equal to each other. And the way that we show that two parts are equal to each other is by drawing that one line. So this side and this side will be equal to each other, while this side and this side will be equal to each other. So if there were some equations involved, I would be able to set each side equal to each other and go from there. Okay? All right, next one. If a parallelogram or a quadrilateral is a parallelogram, the opposite angles are also congruent. So again, they have the same measurement. They are equal to each other. So in this case, the opposite angles go like this. So completely opposite diagonal. And again, they are showing that they are congruent because of the number of marks on the angles. So because these two have only one mark, then I know that they're equal to each other. And then the other ones have two marks, so I know those two are equal to each other. Okay? Next, if we have a parallelogram, the consecutive angles are supplementary. So let's talk about these two things. Consecutive, these mean next to each other. Okay, so two angles next to each other are going to be supplementary. The word supplementary means that they add to 180 degrees, so a lot going on here. So let me show you. This would be a pair of consecutive angles. So together, those would add up to 180. These next to each other like that also are supplementary. Okay, so they're going to have more than one set of consecutive angles, and you're going to have to do the math that way to solve for 180. Okay, the last one here we have is that if we have a parallelogram that has one right angle, then that means all of them are right angles, okay? So in this picture, even if I just show that one is it, you can automatically assume that all of them are going to be it. And why can I do that? Well, I know that if it's a parallelogram, the opposite angles are going to be equal. So then that means this is also a 90 degree. And then I just learned that any consecutive angles are going to be supplementary. So that means the only way this could add up to 180 is if this is also 90. And opposite are equal, so then they're all 90. Okay, that's why this works. All right, so let's move on to some examples here. In example 1, we're told that we're going to suppose ABC where angle B is 32. So this is kind of a tiny picture here, but this is 32 degrees. The segment CD, and I know it's a segment because it doesn't say angle in front of it, is 80 inches. So from C to D is 80 inches. Then I also know that BC is 15. So this right here, 15 inches. find AD. So I want to know what AD is. And then I also want to know what angle C is. Oh, angle C. Okay, so first I think the easiest one is going to be AD to find. So we're assuming that this is a parallelogram because that's what we're talking about in this section. And I know that opposite sides are congruent. So just by looking at this picture, I can say that AD is going to come out to be 15 inches because opposite sides are congruent. Okay, so I just look straight across and I know opposite sides are congruent. Now, this next part, the angle is going to take a little bit more math. Angle B and angle C are consecutive angles. Okay, so in order to find angle C, I need to know that angle C is supplementary to angle B, which means that together they should add up to 180. So 32 plus angle C, which is what I'm looking for, needs to equal 180 degrees because they're supplementary to each other. So I'm going to subtract 32 from both sides. Then I get angle C comes out to 148. So that's what angle C equals. And then that's how I got it, because they are supplementary to each other because they're right next to each other. Okay, so this came out to be 148. Now, if I were to ask you to find angle D, for example, these are across from each other, so angle D would be 32. So that's a different type of problem we could give you on that one. Okay. All right, in the backside, we have a few more theorems regarding parallelograms. And the next one is that if we have a parallelogram, the diagonals are actually going to bisect each other. Remember, the word bisect means cut in half. Okay, so these are the diagonals that we're talking about. And when they cross each other, they're actually cutting each other into two equal pieces. That's what this means. Those are the diagonals. Okay, and then the last one here is that if I have a parallelogram, the diagonals are going to separate these into two congruent triangles. So if I were to draw the diagonal, so that's from corner to corner, this is going to cut this into two equal triangles. So this triangle is going to equal this triangle. So that's another purpose of the diagonal in a parallelogram. Okay? All right, so let's jump into a few more examples given this. We are looking for, in this case, the value of R and S. So let's see where R and S are. I see a 4R here, and I'm going to set it equal to 18 because they are across from each other, okay? So I have 4R equals 18. I'm going to divide both sides by 4. R equals 4.5. Okay, and then just for fun, we're also going to find T here, so that we know how to find all three variables. Next, I am looking for S. S is, it's pointing to this segment right here. Okay, and then I also have another S over here. So it looks like these S's are in a diagonal. And remember up here, we talked about how diagonals bisect each other. They cut each other in half. So I'm actually going to be able to set 8S equal to 7S plus 3. Because they, when they intersect here, it's cutting into two equal parts of that diagonal, okay? So I'm going to subtract 7S from both sides. That's going to give me 1S equal to 3. And that's my answer. And then the last one I added was T, even though I wasn't part of it there. But T we're going to find by, so here's this angle T. And what's actually happening here, because this is a parallelogram, let me draw that line again. This parallelogram, these are two parallel lines. So if you think about semester 1 and this would be a transversal, okay? What's happening between this angle and this angle where 2t is, these are going to be alternate interior angles, and alternate interior angles are congruent to each other. So I can actually set 2t equal to 18 to solve for t. I'm going to divide both sides by 2, and I get t equals 9 in this case. So this one's kind of throwing it back to first semester again, where we had to talk about alternate interior, alternate exterior angles, and in this case, these are alternate interior angles. Okay, that's 2t and 18. Okay, so moving on to number 3. Number 3, we have another parallelogram, and we're looking for the value of k, x, and I'm going to add one more for fun here, p. Okay, so again, I think starting with p is going to be a little bit easier. 2p is here, so I'm going to take 2p and set it equal to 22 because they're across from each other. I divide both sides by 2, and p comes out to be 11. Then if I want to find x, well, x is here, and I know that the diagonals are bisecting each other, so I can set 6x plus 2 equal to 4x plus 12, and then start solving for x. So I'm going to move the 4x over. That's going to give me 2x plus 2 equals 12. Then I subtract the 2 over, which gives me 2x equals 10. And my last step is to divide by 2. So x comes out to be 5. And my last one for k is here in this angle, and then I know that that's going to be alternate interior to this angle, meaning they're going to be congruent. So I can set 3k plus 4 equal to 25 and solve from there. So subtract 4, 3k equals 21, divide by 3, and k comes out to be 7. And that would be my answer for that. All right, so let's go into the last little bit here. In my next example, is asking me to determine whether this quadrilateral is a parallelogram and to justify my answer. So all I have here is that I have two pairs of sides that are congruent. So I have opposite sides are congruent. Okay, and this is the case for both of them. These sides opposite are also congruent. So yes, I can assume this is going to be a parallelogram. Okay, so again, parallelograms, we just make sure that the opposite sides are congruent, and then if we're giving other information about the angles, we can use that too. So going on to this last example, example 5, find x and y so that the quadrilateral is a parallelogram. So in this case, again, I'm going to set opposite sides equal to each other. So to solve for x, I have 4x minus 1, and I'm setting that equal to 3 times x plus 2. Okay, this set of parentheses means distributive property. So we're going to distribute the 3 over, which gives me 3x plus 6. And then on this side, I still have 4x minus 1. I'm going to subtract the 3x over to this side. That leaves me with 1x here, minus 1 equals positive 6. Then I'm going to add the 1 to both sides. So x comes out to be 7. Okay, and then I'm going to do the same thing to solve for y. So I'm going to take these two sides and I'm going to set them equal to each other. 3y plus 1 equals 4y minus 2. Again, the parentheses means distributive property, which gives you 3y plus 3 equal to 4y minus 2. So I'm going to move the 3y over this way. That leaves me with 3 equals 1y minus 2. And then I add the 2 over to the other side. So y comes out to be 5. So these are the values that would make these two sides equal to each other, meaning that we would create a parallelogram. Okay? Now, if we were doing 6.3, 6.3 is just going to be proving parallelogram. So that's where this piece of the notes comes in. Like I said, we're not going to go through it, but if you were going to prove that in a grid and an XY axis, a picture was a parallelogram, you would have to show that both pairs of opposite sides are parallel. We would do this by using the slope formula. So looking at the slope, and that's where you would take the rise over the run. So this is y2 minus y1 over x2 minus x1. Okay, you would show that both pairs of opposite sides are congruent. So this would mean you would be doing the distance formula for opposite sides. And this is the long one, right? So distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. You would also have to show that opposite angles are congruent. So just looking across, finding the angles there. Show that the diagonals bisect each other. You could also use the distance formula for that one. And show that the pairs of opposite angles are both parallel and congruent. So here's an example of, having a graph and needing to show whether this is a parallelogram or not. You would want to use the slope formula. So even though we're not necessarily going to go through this in class, we could figure out the slope really quick by doing just rise over run. So we would go rise 2, run 3, 4, minus 4. So this would be a slope of 2 over negative 4, which reduces to negative 1/2. And see if this one matches. So this one's rise 2, left 1, 2, 3, 4. Okay, so that one matches. And we would do the same for these two opposite sides. So this has a rise of 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So based on the slope formula, yes, these would be parallelograms. Okay. We would take this one step further by using the distance formula and finding the distance of QR, comparing it to TS, and then again for QT and comparing it to SR. But again, we're not going to do this in this section, okay? If this was on a test for a district final or on one of your standardized tests like the ACT or SAT, those are the formulas you would be using. The slope formula to compare that the sides are parallel across, and then the distance formula to make sure that they are also congruent to each other.